guys, Cal here again, coming to you with the second tutorial in the Where is Poppy series. This is going to be basically covering your first custom entity in goal source. I'm sorry it's taken so long for me to get around to creating this. It's been a hectic while. It's actually I think nearly a year now since I released the first tutorial, and I'm sorry about that, but I'm really running on Valve time these days. But yes, it's going to be fairly meaty and it's going to be fairly in-depth when it comes to the coding side of things. So yeah, thanks for checking it out, and I hope you learned something from it. Basically what we're going to do is we're going to create an entity that loads a mesh, an MDL file, and we're going to call it WIP underscore static mesh. The reason I call it WIP is it's an acronym for Where is Poppy, so that I can easily find it in my hammer list of entities. So what exactly is an entity in goal source? Basically it's a map placeable element that serves a purpose, like a door or a monster or an AI character, and also elements that we can't see but are loaded in the map, such as like a path or a multi-manager, etc. So yeah, we're going to use this as an example for just teaching a bit of basic programming, instead of having to use a cycler or a monster furniture to place a model in the game. Because Valve guys didn't actually place a lot of models in the game. Entities were used as interactive items, and they all had their own specific entity with specific code related to that entity. And there wasn't anything really for placing a static prop or a static mesh that animates a little bit. So a similar entity to this would be, for those of you who are familiar with Spirit of Half-Life, would be env underscore model. And for those of you who are familiar with source modding, it's basically going to be more or less the same as static prop. In essence, it will be exactly the same, but it'll perform more or less the same duty. It's not going to cover, this tutorial is not going to cover the absolute basics of programming, because there is a wealth of information on the web if you go looking for it. This is just going to be for those who are more or less familiar with C++ and want to apply that to a goal source mod. What you're going to need, we're going to need a text editor, you're going to need Visual Studio 2013, the Half-Life SDK, Steam, a copy of Half-Life, and a Hammer editor or Warcraft editor. I'm going to be using Jackhammer, the free version. Basically it's a continuation from the first tutorial, so you should already have this stuff set up. So in order to prepare for coding now, I'm going to have to make some changes to my Visual Studio project. So I'm going to start with back in Visual Studio 2013, open up my project. I'm going to go to my HLDLL, I'm going to go to properties, and what I want to do in debugging is set the path to half-life.exe. So I'm going to browse to that right now. It's going to be in this folder, and it's called hl.exe. There we go. And oh, I made a mistake there. Actually, let me just copy this path. Be careful. It's actually a good thing I did make that mistake, because we should be setting this on all configurations, remember? So I'm just going to hit no for this, and for my target path I'm going to paste this, and then our command argument is going to be game. The game is Where is Poppy, or whatever your mod is called. I'm going to need console, I'm going to need developer options, I'm going to need con debug, I'm going to need a height. Okay, so I did not notice that I was writing that all in capitals. I am sorry. Yeah, sorry about that. So where is Poppy underscore dev console dev on debug. Also, this is important, we're going to need to set it into windowed mode with a height of 720 and a width of 1280. And the map we're going to load is map underscore, it's going to be test underscore 01. Notice that I'm using a plus here. That's and that should be called test, not text. Test 01. And that's important that it's a plus, otherwise it won't load the map. Yeah, so the height is 720, so basically it's a 720p window we're creating, and it's not going to be full screen anymore, so I'm not going to have any issues with breakpoints and debugging inside Visual Studio with the game. I'm going to hit apply. Okay, I'm just going to do Control S to save it quick, and I'm going to move over to Jackhammer, where I've since made a profile for my game. If I can just show you real quick, under the tools section, under game profiles, we have a configuration for Where's Poppy, so you can add a new one, which is what I did, and for that you will have to set up all your directories for your FGDs. I also have a custom one here. We're going to go through how to create and add that later. For our directories, all of this is more or less set up. You just set your mod directory and where your asset maps are and where the model viewer is. So that's kind of all okay. I'm just going to open my map with my mod profile. That's actually from testing earlier on. That's what we're going to be adding. What we want to do now is just change these run parameters. So we also want to add window height of 720, width 1280, and that's all you need in the game. Yeah, here we go. It's going to compile, and that's fine. So it's going to save our settings for running the game. Running the game in windowed mode. So let's get started coding then. What we want to do is we want to open up our HLDLL. We want to go to header files, and we want to go to DLL so that we can add our initial header file. Add new item. Make sure we select .h and start typing WIP underscore static underscore mesh or whatever you want to call yours. .h. And I'm going to hit add. That's going to create a new file here. Now let's close down header files, and let's go to source. Let's go in here to DLLs, right click, add new item. This time we're going to add the same name but as a CPP file. .ip underscore static underscore mesh .cpp. And hit add. And that's pretty much all we need for the creation of the files. So let's start by writing some stuff into our H file. A header file now is basically, well, you should know what it is if you're doing a bit of programming. It's basically a descriptor file for all the parameters and functions that you find inside your source file, your CPP file. So it's going to start with a comment of a generic date, February 2017, which is now. I'm going to give it the name of the file, underscore mesh.h, purpose, static mesh loader. I'm going to close off my comment. Now I'm going to add some preprocessor defines for our header file, which is something you just have to do in C++. So I'm going to basically just set them out now. Static underscore mesh underscore h. And we define the name of our actual header file, which is basically the same thing again. Mesh underscore h. And we have to include some other files that are part of the Half-Life SDK so that we can use their functionality. The first one, this should actually not be all capitals. Include should be, again, not all capitals. Include, we want to include extdll so that we can export things to the engine. We want to include util.h because it's got a hell of a lot of useful functions in there for working with models. We want to finally include cbase because we're going to inherit from cbase animating so that our mesh will load and animate using some of the typical features of the cbase class. Alright, so that's pretty much what we need for all the defines. Now we just start writing our class definition, and that I'm going to call it C static mesh, and it's going to inherit from cbase animating so that we can use some of the stuff that's inside there. And for our first private function, it's going to be called void spawn, and it's going to take a void as a parameter. And the last thing, towards the end of the file, what we want to do is we just want to end that if with the preprocessor end if. And I'm going to save that, I'm going to go over to my CPP file. Actually, I'm going to copy this here real quick. I'm going to paste this in here and just change the name of that. And what we're going to do is start programming our CPP file. So we have to include the header that we just created so that it knows to look there. Otherwise, it's going to give us a bunch of we're going to get a bunch of errors pertaining to it not knowing what the hell we're talking about, specifically the name of the class. And this here function is going to complain, or this IntelliSense is going to complain about that. Let's sorry, we're going to write this here first. Include, and in here I'm going to type IP static underscore mesh.h, and then after that, yeah, basically after that all we need to do is link to the class. This is something we're going to look at later when we talk about our FGD, but basically all you need to know is this is the glue that sticks this class to our level. So when the engine loads our level, it's going to see a little point entity that points to this class, and wherever that's positioned in the world, it's going to spawn this class when it sees that point entity loaded in our level. Otherwise, it's not going to work. So this here is just going to be the name that we're going to actually give it in our FGD file shortly. This is the name of the mesh. Sorry, not the mesh. The class that it's going to be stuck to, which is the currently selected and currently loaded class that we are going to start writing now. So our entity is really going to need a spawn, like I have added in our H file. It's going to need to spawn so that it can enter the world. Let's start adding it. So void spawn. Sorry, I can't just write spawn, it's not C#. I have to scope to it. And you can do that. We're doing 2 colons and start typing spawn, and there it's already there for us. It takes void. And within this, now we have 2 things to do. We have to pre-cache our model, and then we actually set our model to this point class, or set this point class rather to a model file so that it'll load that in the game. Pre-caching means that it's going to preload the model before it loads the level. It's going to read the level, and it's going to see that it needs the model, and it's going to load that into memory. And if it fails, for one reason or other, mainly it fails if the model is missing or if it's corrupt. And if that's the case, then it's going to give you an error, it's going to bomb out of the game, crash, but it's going to tell you exactly what file is missing. So this is why we pre-cache. It's more for this reason I do it now than performance reasons, because most computers nowadays have no problem loading and playing Half-Life. So it's a little weird looking, to be honest, this particular function. Let me just explain it to you now shortly. So pre-cache model, this is a macro function more or less, and what it typically accepts is a character, or a pointer to a character rather, or an array of characters, I suppose, because it can't just be one character, and it's going to pre-cache that model into memory. And what we're giving it is a point. PEV stands for, I guess, pointer to. Actually, I'm not sure what PEV stands for, but basically, it's what is it? It's C-base entity, so it's our player in game. It's our current player in game, if you will. So you can use the syntax here to get to a lot of the parameters of this current entity or class, and this is going to be direct reference to what we're currently loading in the game, and what it sees is what it's loading in the game. So we are taking the model as a string, converting it to, or casting it rather, to a pointer to a char, or a char pointer, and then we're pre-caching that. Don't read too much into it. I found that for a lot of this stuff, it was done because it was more or less the best way to do it back in the day, or it's the only way that works, this older code base. So here we have a function which is called setModel. Basically what it does is it sets the model, And what we give it is its entity, and we also give it the model string, or the path to our model, which is actually probably just going to be a model number because all the models are already cached elsewhere by the system. And so far that's actually all we need to do. I'm sorry it's a little difficult to explain what these things are really doing, but just understand that this pre-caches the model and this actually sets the model. If you only do this, it's only going to pre-cache. You're not going to see your model in the game because you haven't actually loaded it and set it to this class. So I'm going to save that, and what I'm going to do is I'm going to build my solution, and it's going to run real quick through that. And the next thing we have to add is our FGD file. So for that, I'm going to need my text editor, which I'm going to load up. I currently have an older version here which I don't need, and I'm going to start writing a fresh one. Alright, so for that to work, I'm just going to give it a quick comment. There is copy forge game data. Like I said, this is the glue that sticks it all together. Again, I'm just going to give it a generic date, February. If I could spell right today, that would be nice. 2017. I'm just going to give it a little reference to our class. Alright, so like I said, an FGD is basically the glue that sticks our code to our level. So it's only needed for creating the actual VSB, because then there's going to be references to this, what we create here inside the level that we develop. But Hammer needs to use this to find out for creating our actual mesh. I'm going to show you how that works now. So this is currently a point class we're creating, which means it's going to be placeable within the map. I'm going to give it an initial Hammer color of green. I'm going to give it a size which takes mins and maxes of -20 space -20 space -20, comma 20 space 20 space 20. Again, those are mins and maxes. The first three are min position and the last three are maximum position. We're going to be using the studio loader to load a mesh. The class we're looking for, if you recall from our code, this is what we are exactly looking for. So this particular word here is referenced here. So this is where this here is associated with our class, which is this whole thing now. Okay, so I'm going to do a colon here, and we're going to give it a name. In this case, this is the name that we're going to see inside Hammer. I give it a WIP underscore prefix like I mentioned before because I want to very quickly navigate to that entity that we just created. So we're going to load the model file. So this is going to create a little, I guess you could call it file explorer for our model. So if those of you who are familiar with like JSON data, this is kind of a similar idea, kind of, and it's using a key value pair. So the key in this case is model, and it's of type studio, and studio in this case basically just means mesh. Just assume that it means mesh, and the value is going to be, in this case, model. You can also, after this, add two extra items. So for here, what you would add would be a path to model, and it's going to fill that out before you load the game. So it's going to be a path to the model, and then the last item is a tooltip, which is also a string, which people who, if they're starting to mapping with your mod, can open this up and they can read in the Hammer what this function did if you added a tooltip, which you can for users, and I will be doing this at the very end. But for now, just to keep it clean, what you're going to see now in the model editor, whenever you open your entity and you enter the properties, is one option for model. That's all you need to see. So I'm just going to save that now. I already have it here as wip.fgt, so add it into your Half-Life mod. I'm going to add it to where it's poppydev, wip fgd, or whatever yours is going to be called. I'm going to replace it. Perfect. I'm going to start up Jackhammer now. I'm just going to show you real quick how to add this FGD to your game profile. Yeah, you just load your game profile. So in this case I have Where's Poppy selected. I'm going to remove it. I'm going to add it again just to show you the process. Look for your mod, or your Half-Life folder, your mod folder, and there's the FGD file. Excuse me. And I'm just going to hit apply. Okay. I'm going to then load our test map from the previous tutorial. And here it is, our empty test map. And now if we try to add an entity, which is this little light bulb button here, click on that and then click on the world. I accidentally added a player start, which I did not mean to do. What you should do is go to the right here, and I'm going to type WIP really fast, and there you have it, our very own custom entity. Click into the world, and if you recall from our Forge game data file, I set this to green, and the size is 40, so it's minus 20 to 20 on all axes, so it's 20 out, it's 20 deep, 20 wide, and 20 high. Sorry, no, yes, it is actually that high. No, it's 40 because we're clipping under the world as well, so it's 40 units wide, 40 units deep, and 40 units high. But don't worry about that for now. This actually doesn't matter. It's only for visualizing it in Hammer. I'm going to double click on it. You could also click on it once and go Alt Enter, or you can right click and go to Properties to bring up this exact same dialog here. And if you recall, here we have the model that we added in our FGD file. So, like I said, it gives us a little file explorer, and I'm going to explore to Half-Life, Valve, Models, tree.mdl, and as soon as you click that in Jackhammer at least, you see your tree. And yeah, it's as simple as that. It's pretty neat. Now I'm going to just double click it again and give it a rotation of 180 so that it's facing the camera. And I also notice now that the world is kind of clipping this guy, so I'm just going to lift this up a few so that it isn't clipping it quite as much. It's just a rough hack here. Nothing too crazy. There we go. So I assume in the meantime our code is built. It should have built. Yes, 2 succeeded. Perfect. That means that our libraries have been sent over to the mod directory. So if we run our game from here now with our windowed settings, it's going to compile the map, sorry, and it's going to run it directly. So we should see tree using our custom entity. Okay. We're not going to see it because I have to start Steam, at least in offline mode. Hopefully, yes, and I'll try again. It's going to build. Here we go, starting up Half-Life in windowed mode, and bam! Look at this. This is your own mesh your own entity that you created, loading a tree mesh, the Zen tree mesh from Half-Life. And yeah, that's basically all you need to do to create this custom loader. So that's the very basics of creating a mesh loader. One thing you're going to notice is if you go up to them, you can walk clean through them, and that's going to be the next section we're going to cover, which is collision. Yeah, so we'll get cracking on that next, and we're also going to have it so that it animates, because the tree has the option to animate, and we're also going to have it scale. All right, so yeah, for now that's just that part over with, and the next section is going to deal with collisions. Alright, for the collision system in Gold Source, what we need to do is, in our spawn function, which we've written in our CDP file, is add. It's controlled basically using the util underscore set size function, which accepts our entity, and 2 vectors, one for minimum position and one for maximum position of the bounding box. So I'm going to give it a -32. I'm just going to hard code it for now. 32, and we don't want to click the world, so we set the minimum position to 0, and then we'll comma and do another vector, 32, 32, 32. And there's one further thing. Oh, I have to get my brackets right here. Alright, that should be fine. I'm missing a comma, and that's it. There's one further thing we need to add here, and it's called, we have to set the solid parameter to solid underscore box. And there are other options for this too. If you go to the definition, you can see that there is no solid, there's a trigger, there's a slide box, and BSP. But bounding box means that it won't be walkable. So you can set the size of the volume, but if you don't set it to solid bounding box, you're still going to be able to walk through it. So for now, let's create this little box. You remember before this that we were able to walk clean through our model. Now we should be stopped by a little box that we can at least walk up on top of, because it's fairly small. And for some reason the map didn't load. Let me check my settings. I must have made a typo prior to this. Debugging all configurations. It's plus map. I'm sorry. 3 plus map, and then you give it a space test underscore 01. And I'll try that again. So it's going to build, it's going to run. Now it's going to load our map. So now you should notice that we're stopped by it. So whenever I try to walk towards it, there's a kind of a collision there. But it's not too big, so I can just jump up on top of it, and there we have it. This little invisible colliding box at the bottom that we hard-coded. Okay, so yes, now that that's working, there is a bit of a better written up example of how the collision system works inside Half-Life, but I'm not really going to touch on that through the video tutorial because it's kind of hard to explain, but you can read it up through the PDF that's going to be included with this, or the written tutorial on this site. Basically all you need to know is that it's an axis-aligned bounding box, which means that bounding boxes or bounding volumes can only be oriented down any of the 3 axes of the world. They're not oriented to the object's axis, it's just the world axis, so that means that they're a weird looking square all the time and cannot rotate. So we have to work with this limitation, and that means that it can make it quite difficult to know exactly how your bounding box looks and what it represents. So what we've come up with is a method for visualizing our bounding box to see what it looks like around our model. So to do that, we need to actually go to a different file, and it's called util.h. So you're going to have to go to your header section first. So we can add this function. Here it is, util.h. I'm just going to double click, and at the very bottom, what I'm going to add is, I'm just going to put a little reminder that it is me who added this. Util underscore render bbox vector origin vector mins vector maxes int life byte r is equal to 0 byte g is equal to 0 and byte b is also equal to 0. And then just put a semicolon there at the end. Now it should be fine. I'm just going to copy this so we can add it to util.cpp. I'll just add this again at the bottom. So bear with me, this is going to seem fairly alien to quite a few of you. You don't need to redefine these input parameters. This is okay. Okay, so we're going to use the message system to send to the engine a min and max and an origin to render a bounding box, and the life, and also the RGB component, which is the color, basically. So we start with message underscore begin, msg underscore broadcast is PC temp entity. We start writing our bytes. Or TE box is, I guess, temporary entity box. And I'm going to start write coordinates. So coordinates we're going to be writing is the origin, 0, and sorry, not a comma, plus mins 0. So that's the first mins component and the first origin component. I'm going to do the same for the second and third min components. I'm going to set the first mins, second mins, and third mins here, and then do it again for the maxes. So basically what this is doing is just sending over these values to the engine, and then the engine is going to render a box for us based on these values that we input. Okay, you write a short. We give it the life parameter. And we also write byte with R in it. And do the same for G and B. Just copy pasta. No. Don't work against me, Visual Studio. RGB, fine. And then you just have to say at the very end the message. And that's it. So you save that. And since we're already in our header file referencing util.h, we have access to that function in our own class now. But in order to use it, like if we were to put that in our spawn function now, we would never actually see our bounding box, because spawn is only run once at the very beginning of the game before the frames even start loading. So what we need to do is create another function. I need to start that in our h file. It's going to be called animate. So void, and we need to export this to the engine, like so that it can be used for save and load and whatnot. There we go. So we void export animate, and then our CPP we go void c static mesh animate void. Okay. In here, what we want to do is we have to do something. So basically what animate is our update loop, or our think function, for those of you familiar with source and goal source modeling. It's basically just going to set this as our think function, which means it's going to run every time we tell it to in the future. So this is what we use to tell it to run constantly. We go piv next think, which is also basically means next update. Next think is equal to gp globals time plus 0.01 semicolon. So what we're doing is telling it to look into take the current time and then add 0.01, so we're looking into the future, and then we're telling it to run the function again at that time. So basically looping. And then we're going to use our newly created function, render bounding box. We look for our origin, like we said, it needs the origin, and it needs the mins, it needs the maxes. I'm going to give it a life of 1, and I'm going to make it a color of, let's say, blue. Oh, must make sure I fix that there. And a semicolon. So it's going to grab this mins and maxes from, because we set our size, the mins and maxes are going to be set to these here values. And the origin is already set to wherever it's set in Hammer, so it's going to grab it from that too. Now, in order for this animate function to work initially, we have to, in our spawn function, reference to it. So that means writing set think. We need to reference animate. So we need to reference our animate function. So that's setting it to the update function, and then we're going to do the same thing. Actually, I'm just going to copy it real quick so it's quicker. I'm going to do this because this is only going to run once. Once the thing spawns and once it goes in here, it's going to loop around here continuously because this here line tells it to, based on how the engine works. So I'm just going to compile that. Should only take a moment. And what we expect to see is a bunch of dots around our bounding box, our bounding volume, based on what we created. Because remember, this util set size is creating the bounding box, so it's going to be 64 in width and length, because we set 0 to the height, so that it doesn't clip through the world, and then, yeah, it should work. Now I've got a, interesting, Steam crashed. I have to run Steam again in offline mode, so I can get this to use quicker. Should work now. There we go. Straight into Half-Life, and look, there it is. We're visualizing our bounding box, so you can notice we can hop up on top of our bounding box for this particular model and walk around it. Yeah, that's good. So I have a fair idea of what I want the bounding volume or the bounding box for this to be. It should really just be up along the shaft of this particular model. But because when you rotate in Gold Source and Half-Life games, the bounding box cannot rotate with you or move with you, you have to basically think about that as to how would you combat that, since the bounding box doesn't follow the orientation of the model and sticks to the orientation of the world. If you were to rotate this particular model 45 degrees in this direction, it's not going to be properly covered by a bounding volume that's square down this area, down the front. Again, I talk about that a bit better in the written tutorial, but one way to combat this that I found is to provide the user with the ability to enter custom minimum and maximum values into Hammer, and they can use that along with this visualizer to see where their bounding volume is. Another option is to create a clip brush on your model and not use the bounding volumes at all. And the last option is to use a sequence-based collision volume, which is actually what a lot of Half-Life models do. So your sequence, the animation that plays, comes with a bounding volume, and that can also be used for animating our model, for making a bounding volume of our model. And I can show you one like that shortly. Alright, so to create a system where the user can input their own values here and here for mins and maxes, what we have to do is create an interface using the FGD data to Hammer so that the user can input this value. So we basically have to make these two guys into variables. So to do that, we have to go into our H file, and under our export animate function, we first of all have to add another function to read from our FGD file. So we're going to call this the key value, which takes a key value data object, and we're going to have a pointer to our pointer to key value data, and then we have our vector mins and maxes. So what we need to do then is replace our set size with the vectors within here with our mins and our maxes variable that we just created. And we're going to make sure that that there isn't there. Okay. So the next thing we need to do is create the function that reads from our level specific key value pairs, and that's going to be the key value data that we just created. Key value, I need to put reference to our class key value key value data. Whoops. Key value data, and needs a pointer to key value data. Okay, so what we need to do in here is have an if statement, or a couple of if statements that checks for the mins and maxes. So start with our mins. This here function is just basically checking if the string that we are inputting, which in this case is coming from the level, pkvd sc key name, if that is equal to this string, and we're going to call it this in our FGD and hammer. So we're going to look for bounding box mins, and so if what we're getting from the map equals this particular name, then we're going to carry some code out. And particularly what we're going to do is we're going to use a function called util string to vector, which is super useful, and we're going to put into our mins vector the value that we get back from the game, which is going to be initially a string. That's what this function does. It's called string to vector. It's going to take a 3-point string, which basically means 3 values in a string separated by a space, and turn that into a vector object for us. I'm going to take the value this time around. Then we want to set it to true. F handled is equal to true. Alright, so I'm just going to copy this here again, paste it, and put an else in front of it. Oh, there's lowercase else if it's equal to maxes, and we want to check it if its maxes are here the same. Oh, I have one too many brackets, apologies. And then we want, if there is nothing, we want to default to setting C base entity key value p kvd. Basically what that does is it sets something to false if it doesn't get that, if none of these conditions work out, which is fine, which is what we want. Alright, so let's make the changes that use these values in our FGD. So let's open up the Forge game data again. And under model, what you want to start writing is bb mins, which if you recall from just a second ago, we added it here, bb mins. Okay, so we want to write bb mins, and we're taking a string object. Remember, we're converting a string because there is no float object in FGD data. Collision volume mins. This actually needs to be inside commas because it's the name. And then we're going to give it some default values. And notice this is how the string is actually going to be formatted inside hammer. So we're going to give it a nice minus mins box. And we're going to go for BP maxes, string, same again. I'm just going to copy it this time, I think it's quicker. Now the reason we're calling it BB mins and BB maxes and not just mins and maxes is because the word maxes and mins are actually reserved and they won't carry the data over if you try to use them. The same goes for sequence, which we'll notice later on, or which we'll come across later on. So I'm just going to save that. You need to close your Hammer editor unless you have a version of Hammer that reloads the FGD data. I'm going to start this up again. I'm going to open my map. We have our model here. I'm just going to delete it real quick and add it again. Use my prefix WIP. Click. And I know exactly where my model is, so I'm just going to go model/tree.mdl, enter, and my model appears. Now, you notice these are the defaults that we had added in our FGD data. Here they are. And these are the names that we just created. So, if we were to change this value here now to something really big, which I'm actually going to do, so I think for the minimum value, I'm going to go -28, -28, 0. Now you have to make sure that you keep a space between all your values, otherwise that function string to vector is not going to work correctly. And here we're going to add 28, 28, 190, which would be a pretty good size for this particular model. Now, I'm going to go back to my code real quick and I'm going to build this. It should be fine, it should include a new key value function. I'm going to run the map, build the map rather, and then run it. Our new values should be taken into account because we can see with our visualization, and there it is. So we have this kind of nice shaft that goes up the middle center of this model, which is kind of a bounding box that you would want for this particular style model. And yeah, that's basically what you have to do. It's going to start in this position at -28, -28, and 0 is flat with the world, and it's not clipping down through the ground. And the other value is 190 in height on the Z, and also 28 out, 28 in width and 28 in length. And that's pretty much all you have to do to set up a manual box to work like this. But what we're going to do next is add a solid flag so people can turn off their the ability to walk through it or turn off their collision if they want. So if I check the flags here, we currently have none. So we're going to create one here now that's going to basically disable collision or enable collision depending whether you have it checked or not. So to do that real quick, I'm going to go back to my code, into my header, and what I do is I add the following define to our header. Solid 1. So we have a solid 1 here. Yeah, that's right. And then in our spawn function, what we're going to do is just save that real quick. What we're going to do in our spawn function is encapsulate the section where we actually tell it to enable the collisions. We're going to encapsulate that with a condition, a lowercase condition. And what we're checking for is if the F bit is set, if bit set, and we're checking if currently spawn flags is set to IP underscore is solid, which we just created a second ago. Basically what this does is it's going to check our model for a flag that's called WIP is solid. Well, it's actually not going to be called that, it's going to be referencing directly to whatever this value is, and it's currently 1. So if the first flag is set, it's going to check if it's set, and if so, it's going to enter this if statement. If it's not set, it's going to continue on and not enter the if statement, so basically not enabling collision. So that's basically how flags work. We also have to define it though in our FGD, so to do that we have to add something called spawn flags. And just make sure that its type is flags, and this should all be lowercase, sorry. Spawn flags, its type flags. It's not a colon, sorry, it's equals, and then it's a little array of square brackety elements. And the first item, or the first flag, we're going to give it a name of solid with a question mark. Is this thing solid? If it's set to true, then it will be solid, and its default value is on. Okay, so this number represents the index of the flag. So basically in Hammer, to check flags again, it would be this one. This is the first one. If I hover over it, you'll see it says 1. This gives us the name that's going to be next to it, and this is the default value. I'm just going to save that, and I'm going to close Hammer so you can see this in action. And under flags, here we go, we have our solid. And for some reason it didn't take the default value. Actually, no, I didn't take the default value because for some reason it's bugged. You have to create a new version each time you want the default values to work. So let's just make sure that we check it. Okay, here it is, it's checked. It's default, it's on by default. And these defaults are coming through, and the model currently doesn't have a default, but we'll add one for that later. And that's our model for the tree. And now let's basically test that out. So in our game now, let's disable this flag. Let me build it but not run the game. Let me return and actually compile the code, because I believe I haven't compiled that code yet. Or maybe I have, but let's see now real quick when we run the game that we should be able to walk through this mesh. Yeah, there we go. So we've disabled collision. And to enable collision again, we simply in our level editor have to turn on this condition and build the map one more time. Okay, our box is a 16 by 16 by 16 box because we used the defaults again, but the collider is there. If I had the proper value set, it would be it would colliding the whole thing. But you do remember that we didn't have this visualizer before, because it would have been a tiny dot in the very center of the world, because the min to maxes that would have been provided would have been 0, 0, 0 all through. So yeah, if I'd given these the proper min to max values, this would work. And you can see when I step up on it, the collision works. Alright guys, so in this section we're going to cover adding the option so that the user can use a sequence-based collision as well as the manually entered mins and max values. So first we're going to need something to switch between them on the Hammer side. So first you enter your header side, sorry, your header file, and let's add wow, if I could speak it would be great. Let's add a variable, let's make it an unsigned short, so we don't need a negative value, and a short's more than enough. We're not going to have any huge values here. We're actually just going to be using 1 to 3, or 1 to 2 rather, with 0 being 1. I'm going to call it member int collision mode. I'm going to save that file, and then here in our spawn function, where we were checking if it's solid, we go in here, and we're going to have a condition to use the different mode, because there's a specific function called util extract bounding box, which takes a sequence number and writes to our minimum and maximum vectors as an output. And that's perfect for what we need right now. So this is already part of the util class, and we're going to make use of it now. So let's add our condition. Let's check if our newly created member int collision mode is equal to 1. Then what we're going to do is, we're going to set size. That looks fine. But if member int collision mode is equal to 2, we're also going to set the size again. But before we do that, we're going to grab the size from this newly created function I just mentioned to you. It's called extract bounding box, and it actually isn't part of the util class. It seems to be part of cbase animating, so this is why we inherit as well from that, because we get useful functions like that. So extract bounding box, which is like I said before, it takes a sequence as the first parameter. It's time we're just going to use the first sequence, which is 0, and we're going to write the min's value from that sequence and the max's value from that sequence into our vectors that we have already created. And then the size is going to get set based on what is placed into these variables in this function. So this function is going to set these values, and then this value here is going to set the collision box. Okay, so that's all good in theory. So let's do one more thing, where we add this condition, or this check rather, to our FGD. So we need to read it in to check if it's actually there. Let's do a little if statement. If the string again is equal to vd name, and I shouldn't have hit enter back there. If this name is equal to, I'm going to call this collision mode. I think you can't use capitals, I'm not sure, but I'm going to just follow what the Half-Life FGD does and not use capitals. We must also make sure that this thing here is an else if. Well, I don't think it needs to be, but there's no harm in making it an else if. Then here's what we do. We set our newly created value using a char to int function, and we take in the value from the game, or the level, the value that we're going to set to our entity in the game. And I'm just going to grab this here again because I'm lazy. So let me just recap. This thing here is going to grab the name from the game, and it's going to check if this name from the game on our entity is equal to this, which it will be. It'll be called collision mode. It's going to enter here, and it's going to set our member variable to the value that this key has been given, which in our case can either be 0, 1, or 2. 0, nothing's going to happen. There's going to be no collision. 1 is going to be the manual inputs that can be placed in our min and max things that we did in the last section. And the second thing is going to be sequence based. So let's add that to our FGD now. And so move on over. And what we want to do is create under our spawn flags, let's just call it, like we know we just did, collision mode. And we're going to call it choices, which means it's going to give us a little drop down in Hammer to choose from, which is convenient, I must say. Definitely convenient. I'm going to give it a name called collision mode. We're going to give it a default value of 2 because I personally want to use my sequence box more often than I want to use my manual values. Manual values are really just for weird looking shapes. So none for the 0 position, and for the second choice rather, we're going to call it manual inputs. Oh, man, I need to get my inverted commas working here. And then the third thing here is sequence based. So that's the third choice in the sequence based multi-choice box. So I'm gonna close hammer and open hammer again, and we're gonna open our level, and I'm just gonna okay, I don't need to remove my entity. I can open it up and we can see collision mode has been added, and we have a multi-choice with our newly created inputs. So none for nothing. If I created this entity for afresh, it would have been actually set to sequence based, which is what I want. But let's show the difference between the two of them here. We have, let me just move this here over a little bit. I'm going to copy it with Control V. And I'm going to enter this one and give this one the manual inputs, which is going to be -1616, that little box we saw earlier on. And this one is going to be using the sequence based. So I'm going to compile my code. It's going to succeed by the looks of it, which is good. And then I'm going to run my map with the two new entities. And for some reason we're actually missing the second entity, which is odd, to say the least. Wonder why that is. Oh, I know why it is. It's clipping. The origin of the model is clipping through the world. So that's another thing you have to keep an eye out for in Half-Life. Things inexplicably disappearing for no reason. So move him back off. We should see both models now. And here we go. So this is our model using the sequence based. So it's going to take the bounding box of the whole sequence and encapsulate our guy inside it. And yes, we're colliding with this whole giant area. It's so accurate, isn't it? And then we have this little box, which is the 16 by 16, or rather it's a 32 by 32 by 32 box, if you take into account that it's -16 to 16 range. And yeah, basically that's it. So now you have a choice to use either the sequence or manual inputs. Okay, here I'm just going to cover real quickly the issue with rotating and axis-aligned bounding boxes. There is no rotating for axis-aligned bounding boxes, basically, so you kind of lose out. If you were an object-oriented system, the bounding box would rotate with the object, which would be fine, but we don't have that luxury in Half-Life because it's axis-aligned. So let me demonstrate this a little better. If I were to take, for instance, this here, particular mesh, and just square up it a little bit, I'm going to enter its properties, and I'm going to rotate it. I'm going to turn off Smart Edit so I can edit the angles a little better. Let me see what happens if I make this 90. Okay, perfect. We're on 90 on its back. And what happens if I make it 180 here? No, let's make it 45 here so that it's facing towards us. And 180 like so. No, that's not correct. I think this here needs to be 180. Also not. Oh. It's hard to get the values right because the system isn't exactly what I expect it to be. Anyway, unless it needs to be up. Let me just see. Yes, this is what we're looking for. We're looking for the up system. Okay, so if I now take our model and frame up a little bit better and move it up in the world to here. Let's just assume that I'm going to increase my definition over here a little bit so that I can bring it down to look like this. I'm going to change the value to 45. And I'm going to pull it across a little bit more. Here we go. Now, the problem here is now that in Half-Life, no bounding box is going to face like this. Basically what would happen is the sequence box would be created, but it would not rotate with the model. And I can show you that now real quick. So for this model, I think it was already using the sequence mode. If I remember correctly, 2 is, yes, sequence based. If I compile this now and enter it, you're going to see that the collision box didn't even move a little bit. It's going to stay where it was. The origin will move, but it's not going to rotate to face the right direction. Okay, for some reason that's facing the wrong way, but whatever. The bounding box is the important part here. So like, what do you do in a situation like this? You could create a giant box that encapsulates the whole thing, but it's going to be like massive wasted space. There's going to be wasted space here, and there's going to be wasted space over here. The only thing I can think of for weird looking models like this that are at like angles between 90-degree axis angles is to like something like, for instance, 45. Like that's an angle where it's obviously skewed down a non-axis, between axis rather, and for that we're not going to be able to use bounding boxes very efficiently. What I propose we do is create little boxes or little solid BSB brushes. Let me just make sure that this angle is actually set right there. Yeah, I thought so. Let me just move this over now. Okay, so what we're going to do is we're going to create a little box here, and I'm going to definitely move it up because that's way too high. Okay, I'm going to bring this down a little bit, so I bring this in a little bit, bring this out a little bit. Okay, so it's kind of covering our model fairly decently at that point. What I'm going to do is right click, create object. We have this little box now. What I should have actually had already done was set the thing here to clip, because that's exactly what we want to do. So I'm going to have to use the texture application now to set it to clip and apply. Basically what clip is, it lets you see through this solid geometry, but it won't let you walk through it. And it's used like for things like doors when you don't want to let the player walk through it at certain points. If you're familiar with it in the source engine, it's called player clip as well. So what I'm going to do now is I'm going to copy this mesh and I'm going to move it so it's here. I'm going to scale it down a little. Get my selection again. I'm going to scale it down a bit and in a little bit here on these sides, and move it some more. I'm going to copy and paste that particular box once again down here. I'm going to scale it. Like, it's a little time intensive because we're working with Half-Life here, you know, it's not exactly the Unreal Engine. It's ancient, or Unity for that matter. But some people, crazy people like me, like to do this. Do not ask me why. I guess you could call it a death wish. And then I'm going to add, bring that out one more. I'm going to add another one down here at the head. I'll bring it up a little bit longer like so. And I'm going to position it so that it's straight down, flush with the model, and that more or less should be perfect for like any weirdly shaped model. Like obviously you're not going to rotate the tree in this direction, but if you had a model that was a long shaft and you just wanted to rotate it so it would look a little different, to have accurate collisions you're going to have to use brushes like so. They're not even going to be accurate at that, but at least they're going to be faked or feigned fairly well. So I'm going to run the game and see our creation in action. Okay, I'm definitely colliding with something. The mesh just hits me right now. Sorry guys, hold on, let me just hit the mesh again. This does happen sometimes. I wonder why it, yeah, now it's not really a problem anymore. If I type 270, it's now facing in the right direction. These are also some of the kinks that you end up having to work through with Half-Life, so I'm just going to move my conglomeration of bounding volumes to further encapsulate this guy. It's dirty, it's hacky, but look, yeah, like I said, this is gold source. This is just how the guys did it back in the day. Well, I assume they did, but this is how I'm doing it now anyway, so it's going to have to stay like that. Build the map. Let's see how it looks. It's a lot easier than figuring out calculations for crazy bounding volume. So, here we go, you can see that we're clipping. We can't, okay. This here is actually still on. This is one thing you should actually do as well. I should have done this already, is disable. You don't need two bounding volumes now. One that you've created in the map and one that's on the actual mesh itself. So to do that, the easiest thing to do is disable solid, because if you recall from our code, if the solid function isn't called, none of the bounding box stuff is going to be done. Nothing's going to be carried out in here. It's going to skip clean over this here, and it's going to go through. And of course, it's still going to render this. We're going to fix that later. But it's not going to do any of the bounding box calculations. So disabling that flag and building your map once again is going to basically disable that bounding volume that comes with the model, so that you're left to use your own static. Yeah, here we go. I'm colliding with stuff here. Yeah, there you go. Stuck. Oh, and if you see, there's the little dot I was telling you about earlier. That's drawn at the pivot origin of the model. So that's what's going to happen there if you don't have a min and max value set. And I can walk clean over, but like it's somewhat realistic. Yeah, you mean, okay, I can't hit this thing, can't hit this thing. It's a little lighter here. I might be able to step, oh look, I can step clean up over it, and there you go. So yeah, just keep that in mind if you have any weird shaped things or slightly rotated things that you might have to just draw out with BSP brushes or CSG geometry, your own bounding volumes. And yeah, that's pretty much it for the bounding volume. Now what I also want to do is, for our bounding box visualization aid, the little blue guy that draws around our box, I want to make that also modular. I'll give people the choice whether they want to render that box or not, and we're going to use a second flag for that. Okay, so then let's set up this bounding box visualization aid to be an optional choice for the user to set as a flag in Hammer. First thing first, let's go to our header file. We need to add but our first boolean, lowercase, boolean m_b for boolean debug bb. I'm going to set it initially to false, because that is what I want our default value to be, so that people don't always see this bounding volume at the beginning of creating this entity. bb2. I'm going to save that. I'm going to go into our spawn function, and it's going to be within the solid check that we have that we're going to add a check for our debug option, our debug visualizer option. So I'm just going to grab this here again. I'm going to put it in here. I'm going to replace this with WIP_debug. There we go. And what I'm going to do is, if the debug bounding box variable is set, or flag, sorry, is set, we're going to set m_b debug bb is equal to true, which means show the bounding box. But how are we going to use this to control showing the bounding box? Well, it's simple. We go into our spawn function and we do a check here for if m_b debug bb. If that's true, oh god, these parentheses. Okay, well, if the debug is true, which is only going to be set when we spawn, because we only want to run this function once. That's why we're doing it within the spawn, within the solid, by the way. So if the solid setting isn't set in the entity, this thing's never even going to run anyway, because there's no point in showing something that doesn't exist, because the purpose of this particular function is to only show the bounding volume. So if there is no bounding volume, let's not be showing nothing and wasting resources. So basically, yeah, we run that function once, and we set this to true. If it's true, it goes in here. If it's false, it never renders the bounding volume. And that's cheaper than doing this here directly in the animate function and doing this every frame, rendering or calculating that every frame, because it's totally unnecessary to calculate that every frame. So that's why we use an intermediate variable for that. Alright, so we do have a small little thing to change then as well in the spawn flags of our FGD. So I'm going to build this really quick. And while it's building in our FGD, look for our spawn flags. Here we go. Spawn flags. And in our second spawn flag, I'm going to add something called debug bounding box with a question value, because we want to see what it looks like, basically debugging it. And no, I don't set this to 2, I set this to 0 because that is the default value. Yes, we don't want that enabled at the beginning. And then what I'm going to do is start up, I'm going to save my level, and I'm going to restart Jackhammer so that I can get access. And actually what I'm going to do is I'm going to clean out what I've already got in here, because it's a little unnecessary right now. I'm going to start a little fresh. I'm going to set up our custom entity and place it there. I'm also going to show you in the future now how to set a default model to load there, so you don't just see this red or green box that you've created. Excuse me. So that yeah, you don't see you see a model straight up, as opposed to just a red box and hammer. Okay, and here's a new flag. So I'm going to create 2 of these models. So let me just bear with me for a moment. Models /tree.mdl. Perfect. And I'm going to duplicate that. Oh gosh, it's went through the world again. There we go. Move it over. And for the flags of the second one, I'm going to enable the debug bounding volume. The collision mode is going to be sequence-based for both of them. If I am not mistaken, yes, it's sequence-based for both, but we're only going to see the collision on one of them. So let's run that. We should have compiled our code. Yes, it has succeeded. Perfect. So the game's going to run now. And there we have it. This is the one that we enabled the bounding volume on, the visualizer for the bounding volume, and the first one has a collider, but you can't see it. And this one you can see, which is perfect. Awesome. So let me just show you one of the caveats or issues with this particular thing. I'm going to duplicate that particular model. Excuse me, I'm going to duplicate it again. And like I was saying, duplicate that model. And now what I'm going to do is Yes, I think duplicating it's enough. I'll do one more duplicate. I'll move it across over here. So basically what I'm trying to demonstrate is that this visualizer is not infinite. There is a certain amount of these temporary entities that we can spawn in the world, and it's not enough really, so or use it sparingly if you want to see. But I just want to show if you come up against the same issue, this is what you're gonna see. Ah, yes, perfect. So the first model is fully enclosed with these little temporary entities that are flickering. So basically I think what that function does on the engine side is it's just checking the vectors between the max position and the min position, and it's drawing lines, or rather dots, which I think are very tiny little sprites, which are technically also entities, and it's drawing them between these vectors. And I think, like everything gold source, there's a limit. You know, there's a lot of limits in gold source with certain things, and this, for one, is a limit. So you notice with the second one, it finishes up here. Like it draws part of the box, and then it ends up here at a cap. I could probably calculate exactly how many of these there are if I were to make certain squares of a certain size and then see where it ended up running out, but there's no need to do that. This one here is also supposed to be rendering its bounding box, but it can't because it doesn't have enough entities. So if you run into that problem, there isn't a problem really. If you run into this, it's not a problem. It's just the visualizer has run out of temporary entities to render. So take it off one of the models and enable it on the other. Most models won't have bounding boxes this big either, though. They'll be considerably smaller. So you shouldn't have that problem. And yeah, that's pretty much it for that particular visualizer. There is one other visualizer I'm going to touch on now, just real quick. Half-Life has two rendering modes. It has a software renderer and a hardware renderer. And the hardware renderer is OpenGL based, and the software renderer is, I think it's internal to Half-Life, and does everything on the CPU, I think, instead of the GPU, or emulates what a GPU should do, rather. And it kind of looks kind of crappy as well, so it doesn't have the same amount of resources a hardware solution does. So there was included with the software renderer a function called, let me just type it out real quick so you can see this. It's called r_draw entities 5. There is this function, and it actually goes from 0 through to 5. 0 means don't render any entities in the level up. 1 is the default, render the entity in its normal state. 2 is render the entity's skeleton if it has one. 3 is render an entity's hitbox. And 4 is render an entity's hitbox as translucent with the model underneath. And I'm going to show you all these now in a moment, but there was a fifth option in the software renderer I learned that lets you see the bounding volume based on the current sequence the model is playing. It'll render for all the entities that are currently loaded in the model because it's a global thing, but it'll only render the bounding box of the sequence that the model is currently playing. So if it's playing a different sequence, it's going to render a different bounding box. I'm going to demonstrate this later, but I want to actually show you how to enable this in the hardware renderer, because I don't know why it was never enabled for the hardware renderer. It should have been, but it wasn't. So in order to do this, we need to go to a file in, I think it's on the client side, I'm not exactly sure, but the file we're looking for is Studio Model Renderer CPP. Will you see if it's here? No, it doesn't look like it, so I think it's on the client side. So let me go to HCLDLL, we go to CLDLL, and we're looking for Studio Model Renderer.cpp. Let me just enter that file, and let's look for a particular function. We are looking for, what are we looking for? I think it's part of the render. Yes, here we are, Studio Render Final Software. And what this has, actually there's both a Studio Model Render hardware and a Studio Model Render software. there's a bunch of conditions which are checking the CVAR or the console variable for what value we input. So 0 is going to render, here we go, it actually says it, Studio draw bones. The third one is for drawing holes. 0 draws nothing. 1 will draw the correct entity, so I guess it doesn't need to be changed here in the final thing. But the fifth one is the interesting one. Here we go. It's iEngine Studio .studio draw absolute bounding box. And this is what we're actually, all I'm going to do here is copy that, and I'm going to scroll down to my hardware render, which is this here function, and just before this end restore renderer is called, I'm going to plop that in there just after number 4. And I'm going to go Control S to save it. I'm going to build the solution, so it's going to build the code for my client DLL now. And what we're going to do is we're going to go into game, and we're going to enable this console variable. I'm actually going to go through them all with you now, just so you can see them. Prior to this, it was only available in the software renderer, so what you would actually have to do is go to Options, Video, and I stumbled on this by pure chance, looking through old console variables for Half-Life. You would have to change the whole software, the whole renderer to the software thing to enable this, but as we've just changed the code, we can see it in OpenGL, which is what we're currently rendering through. To enable that, let's go to r_draw entities, and it's already giving me something. So currently it's set to 1. If I set that to 0, notice in the background our models have disappeared. Our bounding boxes from our entities, funny enough, are still rendering because they're not actually part of this function. So set that back to 1, we see our entities. 2, we see the bones of our entities rendered as little grey boxes. And you can move in and have a look around at them. And this is a pretty useful thing if you wanted to debug how the hell your bones are working in the game. I'm sure they must update whenever an actual sequence is playing. We can check that out later if we have time. 3, this shows the hitboxes. So this is used for hitbox code in Half-Life, which is something even different to take a damage and whatnot. Different hitboxes have different damage values. The fourth one is going to show hitboxes, but it's also going to show your model through it. So your hitboxes are translucent, but your model is rendered normally underneath it. So it kind of gives you a clean idea of how your hitboxes measure up to your underlying model. And here we go now. Prepare. Number 5. This shows you your bounding volume based on the sequence it's currently playing. So if you see here, look, this is our temporary entity function we created. It's matched up perfectly with the bounding volume of the mesh, and these are all sequence-based ones, because the sequence is actually quite big for this particular model, the Zen-tree. Now, what I've noticed is whenever I run this on something like a scientist or whatever, and I ask the scientist to follow me, we can actually do that real quick, just to show you. I'm going to go into Hammer. Let me see if I can add a scientist. What does scientist come in under? I think it's monster scientist. I'm going to drop a default scientist in there, and I'm going to ask him to follow me, all the while enabling this new draw mode that we just enabled. So here we go. r_draw entities, and I hit 5, and we see the bounding box around him. Now you can see as his animation, which is his sequence in this case, changes over time, his idle thing changes, the bounding volume is going to update with that. Okay, so his sequence changed, the bounding box is bigger, it just grew a little bit. And if I ask him to follow me, his bounding box changed to the walking sequence, so it's a specific size and it follows along with him, so that it gives him some, and he was running there as you noticed, and now he's standing still and it's got smaller again. So this particular method or console variable is very useful for debugging collisions on a model that is using the sequence as the bounding volume. But if you're using our manually set one that we created earlier, you're not going to have any luck because it does not represent the manually set one at all. You're just going to have to use our temporary entity one for that. And that's why we added that function. So that's pretty good for now. I'm quite happy with that. The next section we're going to cover is going to be animation and how do we actually enable sequences, because you can see in Hammer right now these things are animating in here, but they're not animating in game, which is just typical of Hammer, to be honest with you. But we're going to sort that out now and change that, and yeah, we'll do that in the next section. Alright guys, let's get started on the animation then. You might ask like why we even want to include animation on what's supposed to be an inanimate static object. Well, for instance, take a bush or foliage. It tends to sway in the wind. Like I'm not saying that I'm going to be using that for my mod, but somebody might be, you know, and they might want to know how to enable animation on a static object. Why not? It's also part of the tutorial, so let's get cracking. Back to our header file, let's add a second integer. I'm going to call it mi sequence, and we're going to have to then go, I'm going to save that back to our CPP file. Let's go to our key value function here, and let's add animate. I'm just going to add it at the top because it's just as easy. I'm going to copy this here because I don't know if you noticed before, but this here particular part is different to this. This here is setting a vector from a string. This here is setting an integer from an A, in this case represents char. So it's going to take this value, which is a char, and convert it to an int, which we are then setting in here. So I just copied that whole this whole section. I'm going to make this an else instead, else if. And instead of collision mode, I'm going to call this animate. And I'm calling it animate and not sequence for a reason, and I'm going to explain that in a moment. I'm going to call this m_i sequence, and yeah, char to int, a to I in this case. That's perfect. So we then, in our spawn function, oh yeah, I should actually mention this first now while I'm here. The order at which these things are carried out in or ran in the game. First of all, our key value data runs, and it gathers all this information from our level. Then it runs the spawn function, which initializes a bunch of other crap that basically sets our model, pre-caches it, and sets the collision and whatnot. And then what this does is it sets the thing function, basically setting the update function, and then the animate function will run until the game is stopped or until your entity is killed or whatever. And that's basically how it works. Starts with the key value, it moves to the spawn, and then it continues on with the animate until it ends, if it ever ends, which it probably won't. In our case, we're not going to have it ending unless you kill the game or move to a different level that doesn't have our entity. So in our spawn function, after our check for if it is solid or not, and I'm sorry that there's no comments here. I should be commenting here while I'm writing along, but I guess this is what the video tutorial is for. The end code that you can download from the site or from GitHub will have plenty of comments in that explain these things also. So continuing along, I'm setting the pav sequence, and if you wanted to actually see what pav all holds, you can just I'll show you real quick. Pav, remember, is our entity, our current entity. I think pav stands for a pointer to entity variable or entity value, I'm not sure. But anyway, if you use this here little, as you call it, pointer symbol, you can get to all the members and children of this particular entity. And this is for all entities, all point entities that you create in the game. They're all exported to the engine, and then the engine does with it what you want, I guess you could say. The most important one to us right now is sequence, and that's what we're going to use. And I'm going to set it to m_i sequence, what we just created, because if you recall, if this function is called first, where this here is going to get set by the level or the map if it finds an appropriate entry called animate, and then it's going to call the spawn function, and then it's going to get set here. Now if it doesn't get set, then we're going to have a problem. This is going to get set to null, and that's why in my header file I should actually be setting these things to 0, just in case these things here fail. But for now it's not really a big deal. Now there's one other thing I want to mention while I'm here. I'm going to copy this. This here should actually also be inside extract bounding box. Now why is that? Well, you want, if you're going to be using sequence collisions, you're like sequences from models, like you saw with the sine list a moment ago, it ranged from something that was really wide to really thin. And you want your, if you're going to be using collisions, sequence-based collisions, you want it to update based on whatever sequence you have. So we're going to use whatever sequence we input, and the sequence is going to be supplied by our hammer level. Okay? So it's going to not always use the first one, because that's what 0 represented. It represented the first sequence. Now it's going to use the whatever the user selected sequence is. That's basically all that does. And let's move on to the animate function next. And this is important because what we do here now is we are going to basically set an animation on the code. And what I mean by that is we're going to create like a basic inline ternary operator, which will be used to update the frames for the model. Sorry, I lost my train of thought there and I went completely bonkers. I'm sorry. So I'm just going to go piv, and we're looking again this time for something. It shouldn't be capitals. Piv frame is what we're looking for, and frame controls how fast something is animating. We're going to use the ternary operator, which means we use this and this. And those of you who aren't familiar with it, I'm going to explain it now in a moment. So we're going to check if the frame is greater than 255. And that's typically how things work in goal source. It's not like scalar value from 0 to 1 a lot of the time. It's actually 0 to 255, which is color value if you know anything about your RGB values. But yeah, I'm not going to worry too much about it. Just note that that's how it works. And then what we're going to do is, if it's greater than 255, set frame to 0. So we want it to restart if it's greater than 255. Otherwise, piv frame plus plus, incremented by 1 every frame. Okay, do you understand that? Another way to write that is, and probably for those of you who aren't too familiar with it, is if piv frame is greater than 255, piv frame is equal to 0. Else, I do not know why Visual Studio did that. Oh, I do know actually. It's because this here was messed up. Sorry. There we go. Else piv frame plus plus semicolon. So this whole line basically equals this. So what you're saying is, if this is bigger than this, do this, otherwise do this. You're going to see that a lot if you're working through the SDK code, and just don't be too alarmed by it. It looks weird, and if you don't understand it initially, just run it through your head a few times, and it'll come to you. Like, it'll be like one of those, bingo moments. Little light bulb goes off. It's like, oh, okay. At least it was for me. I'm probably slower than most people, but whatever. Next is what we're going to do is we're going to add this animate to our FGD, our Forge game data file. So now this is where things start getting a little messy, in my opinion, because there's duplication here, and I don't like it. It's not necessary, but for me, I like having the ability to see what animation I'm playing in the editor. Like what you see is what you get in environments similar to Unreal or Unity or CryEngine. You don't have that with GoSource. Everything's, pre-compiled, pre-baked. So what we have to do is hack, basically, to see what something's going to look like in the game. So one of these hacks is the sequence key name. Sequence is reserved, and it's reserved and used by Hammer. And I think the reason why these the words like sequence and mins and maxes, sorry, not capital mins, okay, whatever, maxes and other things are reserved is because in the code, if you do a piv, these things happen to be part of this class. Like I can type mins, there's mins, sequence, there's sequence, maxes, and so on and so forth. Like there's loads of other things. Angles, for instance, also reserved. So you can't use that word anymore. So what I have to do instead is create things like BB mins and BB maxes and collision mode, and in this case animate for the sequence. But if you do use it, the word sequence, and your level editor supports it, you get to change the animation inside the editor as well. It just won't change in-game. And that seems to be a problem with Half-Life. I've not been able to work around it. I have no idea how to work around it. If one of you guys watching this knows how it's done, please tell me and I'll update this tutorial. And I'd be very happy to update my own code, include a cleaner way to do this. So what I'm doing now is I'm just, sequence, like I said, is reserved for the editor. And we're going to have to use our animate keyword that we added to our key value function, and that's going to be used to change it in-game. Actually, that's all I need to do is set that. So animate, that's our next one. This is the duplication I was telling you about. If I could spell right today, integer. I'm just going to copy paste this here. I'm just going to write game in there so that you know, like you can tell the difference. Okay, this one's only going to change it in the editor. This one's going to change it in game. And we're setting it to the 0 sequence, the first one, if there is one. But I think most models have a sequence in this game. So I'm going to save that. I'm going to open up Jackhammer, and I'm going to save Jackhammer, and I'm going to close Jackhammer, and I'm going to open Jackhammer. And I'm going to open my level once again. I really wish there was a refresh. Maybe there is a refresh. If I hit F5, does it do anything? No, that's a save as. Okay, forget that. Now you're going to notice that we have animation sequence and animation game. If in the editor I change this to 1 now, watch it. It changed on our model. And if I set it back to 0, changed. Now if you left it like that, that's not going to work because we don't have a corresponding sequence check in our code. And even if we did, it wouldn't work, as I've tried numerous times, because it doesn't even come to this flippin' function and work, because the engine doesn't even send it. It's reserved, so, and thus ignored. That's why we have to use our own in-game one. And so you would have to then also set this to 1, so that it'll work in game. So be very careful when you use this. Don't just set it in the editor and assume, oh, it's going to work, and then you land in game and your animation's not playing. You're like, what the hell's going on here? You have to set it for the game as well. So let's just check that. I'm going to compile this first. Make sure that we won't have any problems. That looks good. I'm going to compile this here. Have a wee look. So if we wanted to see exactly like how many animations something had, the best thing you can do really is use the Half-Life model viewer, which if you set up your thing correctly, I'm going to select this model, you can go to View Model, or just open it with Half-Life model viewer anyway. And here you go, you have your model, and if you go to the Sequences tab, you can check how many animations it has. In this case it has 2, so idle 1 is equal to sequence 0, and attack is equal to sequence 1. And that directly corresponds to this value that you're entering here. I notice with a lot of the Half-Life stuff, what they've done is they've actually just created a multiple choices thing and added all of these things as choices, which you can do too, that's fine. But this is a static model. You don't know exactly all the time how many animations this thing has, and you just want to plug in a thing to see what it's doing. So that's fine. The next thing we need to do is to add the option as to whether somebody wants to animate or not, because right now it's going to animate irregardless of whether you want to or not. So to fix that, what we need to do is, now I'm going to tidy up the scene just a little bit, because I've got too many Zen trees sitting around. I'll add one in a moment. Back to our code, we're going to add a flag, I guess you could call it, for animation. And the reason I'm adding a flag and not using a control value from which controls the speed, I'm going to explain now, is because of the way that flags work in Half-Life. You would assume now that the next flag you could create is 3, but you'd be wrong, because 3 doesn't exist. The way it sends the data over is using, I guess, bits, which are thus powers of 2, so the next power of 2 is 4, and that's how this is going to work. If you set this to 3, it's never going to work, because it doesn't exist in Half-Life. So let me just show you this real quick. If I go into the properties and into flags and hover over this, you go, you got a 1, you got a 2, 3. No, it's actually 4. Okay, so the next one's 8, 16, 32, 64, 128, 256, all the way up to this crazy number. So just keep that in mind when you're creating flags. This flag technically isn't necessary, but I'm going to create it anyway just so I can demonstrate this feature. I really need to spell correctly today. Animate. There we go. I'm also going to add a new boolean, and it's going to be called m underscore, oops, lowercase m underscore b animate is equal to false. There we go. No, I need one semicolon. Let's save that. And that's pretty much what I was doing in the header file. Okay, so let's go to our C++ file and look for our sequence. Our sequence is here somewhere. Here it is. Okay, so this is where we're going to use our f-bit. I'm going to grab our f-bit here real quick just so we have a quick and dirty way to get to this. P underscore animate. Okay, so if the animate flag is set, then we will animate. That makes sense, right? But we're also going to do this. We're going to say m underscore b animate. Oh, I really can't spell it today, can I? Animate is equal to true. If it manages to get into this particular check. And then what we want to do, similar to what we did for the debug thing, is for our frame, we want to go if m underscore b animate is true, then we want to actually animate, otherwise don't animate. Now there is another argument towards this, is that we can change this frame++ to use speed, which we will now in the future do. And you could use that instead of a flag, but I wanted to show you guys that you have to set the flag to 4, and the next one would have to be 8, and the next one would have to be 16. I just wanted to brush over that. And again, we do the f-bit check in the spawn function, and then we do a check against this locally cheaper variable, animate. So we now have to add this flag to our FGD. It's going to be called 4, also has to correspond to 4 here, because if you write 3 it's also not going to work. Animate, question mark, for lols, and I'm going to set it to 1 so that it's animating from the get-go. And yeah, I'm going to compile this code, build a solution. Meantime, I'm going to set it up in the level. Actually, I need to, of course, restart. Such a pity you have to do this. Okay. Roles, MDL. What we want to do is animate actually wasn't set here, but it should be because its default is 1, but because I didn't make a new variable, it didn't get set, so don't worry about it. Leave this one animating. Okay, I'll start over here with that one, and move this one over here beside it. So this one, we're going to use animation sequence of 0. This one, we're going to use an animation sequence of 1. And the third one, well, hold on. What's the flag? This thing's animating. This thing's animating. Okay, we're going to say for the third one, regardless of what your sequence is, you're not going to animate. There we go. So, let's run this level. Hopefully we compiled successfully. Otherwise we won't see anything happening here. Clipping the world again. I don't know how I didn't notice that. Hold on. Of course. Why is it so high up? There we go. Let's do that one more time. Hopefully we won't have a problem with it. Okay, there we go. So the first one is doing the first idle animation. And the reason it's slower is because this particular animation, if you check in Half-Life Model Viewer, under sequence, it has a maximum frames of 201, and we're doing a check for 255 because typically a lot of models have 255 frames in them for a full sequence of frames. This one only has 101, so that's why it plays slower, because it stretches it out over 255 frames. So in order to fix that, we're going to add a speed variable as well. But for now, you notice that our flag is working. This one is set to 0, or is not set rather, so it's not animating. This one's playing the second animation, this one's playing the first animation, because their flags are set to 1, or true. That's pretty good so far. Now the next thing we want to add is an animation speed variable. So I'm just going to save my file real quick, and I'm going to go to header. Let's add, and this time we're going to add a float, because yeah, we're going to be multiplying or adding to a float rather. And I'm going to call it m_f_l animation speed is equal to 0.0f. The f is at the end to denote that it's a float. So it is. And then what we're going to do is go under our key value data, and there we're going to do a check for if we have a float or not. Just really quick, set that to an else if. I'm going to call this animation speed. I accidentally took too much stuff there. Animation speed. And instead of moving it to an integer, we're going to convert this to a float. A to f also exists, so we're taking the character, which in this case is just going to be whatever we input in. And the majority of these things in Hammer are sent across as characters and then converted to floats, integers, and whatnot in the engine. So instead of sending it to sequence, we're going to set a member float. We only have one float variable, and that's that. And yeah, that's all we have to do in the key value section. Fair enough, next thing we have to do is actually use this variable to check if there's any changes to speed. So we do that in our animate function within. So if we're animating, we're going to do another check in there, because we're also going to add support for playing this animation in reverse. So if underscore fl animate speed. Well, before I do that, let me just show you that the speed thing works before we get too complicated. So what we're going to do is, if the frame is greater than 255, the frame is equal to 0. Otherwise, the frame is equal to frame plus equal to itself underscore fl animation speed. So I'm going to build that solution. I'm going to go to my FGD and I'm going to add our new animation speed variable with the type string, because we're converting string to float. I'm going to call this animation speed, and I'm going to give a default value of 1, because that's what we wanted to do initially. Also make that a string, because floats aren't supported. So I'm going to have to open up Hammer again to give our models an initial speed. This guy's going to get rid of them. Oh, got rid of the floor by accident. Okay, so and IP. Please ignore the dog. He hits everybody. Animation speed is set by default to 1, which is perfect, but I'm going to set this a little bit higher so we can play a faster animation. You're not going to get a visualization for this inside the editor because the editor hits us too. Models tree.mdl. And the editor has no idea that we made these changes to the speed, so it's only ever going to be an in-game change. We made the speed considerably faster. If 1 is default, 10 is a good bit faster. So let's compile that and run. And we have a really fast, weird wobble animation from our model. And yeah, so it works for the speed. You could also slow it down even more by using a considerably lower value. If 1 is normal speed, 0.1 is going to be very slow speed. So let's see that in action. As you can see, it's animating really slowly. And this might be something you want for like a sway in a bush or something, but the option is there anyway, if you want to. Alright, now, some people might want to play their animation in reverse. I don't know why anyone would want to do that, but look, let's make the option available. While at it, since there's not really a huge deal of coding behind it. What I'm going to do is I'm going to copy this here. I'm going to paste that down there, and we're going to add a check here now. If underscore fl animation speed is greater or equal to 0.0, so if it is bigger than not moving, we want it to do its normal animation. If it's anything else, so if it's a negative value, or a value less than 0.0, Okay, that would have to be a negative value. Then we play this other line. So what do we have to do? We have to change things around a little bit. We have to make this, if the frame is less than 0, because we're going backwards now, we set the frame to 255, and then the frame is also, we're still going to keep this as plus equal to animation speed. Yeah, that's pretty much it, I think. Let me just change that, and here we go. I'm not going to build right now. I'm going to make an option here real quick, how this is supposed to look. I'm going to make a duplicate, which also isn't clipping the world. And on this option, the animation speed, we're going to make this negative 1.0. And this one here is going to be 1.0. Alright, so let's see how this looks when I compile. Build that solution. That looks good, succeeded. Let's build a map. Here we go. So it's hard to tell if they're actually in reverse or not, but actually I'll use the other animation for this because that's kind of silly of me to use that animation. Animation game 1. No, let's set to 1 in editor 2. This is, again, the duplication I was telling you about. Not something you really want. Okay, so let's build the map again. And we have one going backwards. It's kind of hard to tell here too, but this guy here is going backwards and this guy's going forward. But it works. Okay, so on to the scaling section of this tutorial. You'll notice if you just, in your spawn function real quick, let's just, after this here go, you notice that our entity actually contains a definition for scale, but this currently is only supported by sprites, and we never actually wanted to scale the view model. I'm not so sure why they never included this functionality. I guess it was never needed. So, and they also built their models to scale in the 3D package and never had to scale them within the game, which is fine. But if you wanted to scale your mesh at some point, you're gonna want to have to make a few changes to make that work, especially for a model, because it's not going to work as out of the box. You can't just say scale is equal to 0.5 f. It'll be half the size. It's not going to work because there is nothing on the client side that's going to change that for you. We have to add that ourselves. So what we need to do is add support for that on the client side, and then we can take it out of the hard-coded values and set it as a condition, or a condition but a value that we can set in our level. Okay, so what you need to look for is in our client DLL again, we need to look for studio model render where we were before, where we added our no, actually we didn't add anything to studio model render. That's a different function. What we want to do now is add the following function in the studio setup transform. So what we need to do is look for studio model render, studio setup transform. Where is that? Studio setup transform. Here we go. And at the very end of this, we're going to want to just before. No, actually after these as well. This is fine. We want to make these changes to scale at the end. There's another thing we're going to have to mention as well, is that bounding volumes aren't going to scale unless we make a change on the server side DLL, but I'm going to come to that now in a moment. So what we need to do is create a condition, and it's okay if you already follow along. I honestly don't understand a lot of this myself, and I came by it by pure chance, and more or less actually comes directly from Spirit of Half-Life, and I'm very grateful for those guys for figuring that out. We're figuring this out. If the scale is not equal to 0, oops, and I'm just going to grab this again because it's easier than typing it out, and the scale is not equal to 1, because 1 is going to be what we're setting as the default value for scale. If it's not equal to either of those, then we're going to change the scale of this model. Because if it's 0, we're not going to see it, so why the hell would we bother rendering it? There's no need to render it in that case. So int I equal to 0, let's do a little for loop. I is less than 3, y3, we have three entries in our matrix that we're going to be modifying. It's a 3 by 3 matrix because it's a rotation matrix. And I don't know why the parentheses hate me today, but yes, that's right. Okay, so it's a nested for loop, so we have a second loop in here. We go int j is equal to 0, and since it's a 3 by 3 matrix, we go j is also less than 3. So we have 3 columns and 3 rows to go through. Actually, no, it's not 3. It's a 4 by 4 matrix because we have to. Yeah, that's fine. 0 is also included in this. J++. And then the actual code that's changing thing is this here. What we want to do is get a pointer to the m_pointer rotation matrix. And we're going to close that, and then we're going to do 2 square brackets. And we're going to go I and j so that it goes through each row and each column and multiplies by the scale that we are inputting. Prior to this, MP, I actually have it copied, MP current scale is set to do nothing. It's just for a sprite entity, it'll do something, but for, because it has code to handle that, for a model entity, a mesh, there's nothing, and that's why we're adding this now. So I'm just going to add a little comment here so I remember. I should get into the habit of doing that. Scale mesh. I'm going to save that. And then we have to move back to our, actually we don't need that there now. Just to show you, back to our header file. We need another float. So what I'm going to do is m_fl model scale is equal to 1.0. And that looks good to me. So, right, like I mentioned before as well, we need to take into account that we have to modify our bounding volumes by the same scale amount. So in order to do that, let's return to our spawn function where we actually set the bounds. There's not the tidiest way to do this, but it is what it is, I guess, at the moment. So what I'm going to do is we're setting mins to mins. And we're going to multiply by m_fl model scale. And the same for maxes. Is equal to maxes multiplied by m_fl model scale. I need to put a semicolon after these. And I'll put a little space there just to clean it up a little. So basically we're taking our mins, we're setting it to itself and multiplying by the scale. And we have to basically do the exact same thing in here. But first of all we have to extract our bounding box. So we get the actual mins and then we modify it by multiplying by the scale, and then we set the actual bounding volume here. So we had to do it in two places, for our manual input and for our sequence input. And that's fine. Then the last thing we have to do is actually what I had set earlier is bev scale is equal to mfl model scale. And that's actually all we have to do, because we don't have to update our model scale in the animate. It's enough to set it at the start. So we have one last item to add. It doesn't really matter where you add it. I'm just going to copy this function. I'm just going to go else paste. I'm going to call this model scale. And call this m_fl model scale is equal to chart or float based on the value that comes from this. And we have to set that up on our FGD. And again, we have another situation where scale is a reserved name, so we have to call it model scale. Scale is reserved, so it means it's used by the level editor as well to actually set the scale, so you can have a quick look at what it's going to look like by setting scale, which we're going to set now too. So I'm going to call this model scale game. I'm going to set default value to 0.0 and scale string I accidentally keep doing that, sorry. Model scale editor, and the default for this is going to be also 1.0. Save that quick. And yeah, let's just check that out, and also let's check out our bounding volume. So I'm going to close Hammer, restart Hammer. In the meantime, I'm going to build my code. Hopefully there won't be any problems, because it also has to build something. Okay, yeah, 2 succeeded, so it also built the client. Where is puppy? I'm just going to get rid of these real quick so our defaults come up again. WIP, static mesh, click, double click, model. Now, just while I'm here, I might as well mention it, the location of all of these directly corresponds to how they are written here, so you can tidy that up yourself if you want to move them around. For now I'm just going to set the model tree.mdl, perfect. The animation speed is fine. Do we want it to animate? We do. What did we add? We added a scale feature, so the editor scale is currently set to 1, but I set this to 0.5. And the game is, it also needs to be set to 0.5 again. The editor only changes it in editor, and game only changes it in game. We can create a second one of these. Whoops. Perhaps I can make something that's bigger. Scale, game, editor, 0.5 maybe. See what this looks like. I've never actually tried to make something bigger than it's supposed to be, so it's clearly clipping the world at the top there. It mightn't actually render, but no, it should, because the point, the pivot or the origin of the model is above board, so it's within. So let's compile the map and have a quick look at this. As you can see, the bounding volume has scaled with it perfectly to encapsulate the whole thing. So this is a half-sized model. We can make it considerably smaller as well if we wanted to. Let me just copy this little guy, put next to him, and we'll make him a scale of 0.2, even smaller. Why not? And let's run the game. And there we have our tiny little Zen tree, complete with bounding volume, which doesn't let us collide with it, which is great. So the next thing I just want to cover really quickly is error prevention. And the pre-caching is one thing that we've covered a little earlier. And yeah, I'm going to show you how to load a little default model to prevent an error occurring in the first place. So I'm going to enter my FGD and look for model. I'm going to move this guy to the top because it should really be the first thing that's referenced. Oops. I need to actually paste it. There we go. And if you remember, we were saying that the second parameter is going to be the default value for this. So you can just type in models. In my case, I'm typing null.mdl because that's what I called it. And if you also recall, then you can set a little tooltip. But for now, I'm not going to do that because I'm going to show you that later when I copy paste to what I've already finished. But what this is going to do now is load a default model for us, which I'm going to include with the project course. You just have to basically make your model, place it in a models folder and the name here, and if there is another one in the Valve directory for Half-Life, it'll use this one first. So our null model is basically this. No model loaded, similar to the error model from source, and it just rotates around so you can kind of spot it. If your model is missing, we're going to throw this model up so you can see it. Okay, we've set that as our default. I'm going to restart Jackhammer. File, test one, okay. Let's create a new entity. And you should already see it now in Hammer when I click. There it is, animation and all. It places our model file and it plays the animation, which just happens to be a rotation along with it, and a simple red color. Now, what the reason for this is, and if you click into the model itself, is you can see that it's already set here, so that gives you the option to set this here, is if I were not to empty this out and it returns to the original Half-Life Hammer box, and I build this level, we're going to get a crash. It's not going to tell us why. It's just going to bomb out like it can, and it's not going to tell us what's wrong. See, Half-Life Launcher has stopped working. There's not going to be any errors. And even if I run this in debug mode with Visual Studio, we're not going to get any helpful errors with that either. So this is why we use a default setting here. But people can be stupid and they can just delete it like I did here. So what we're going to do is add a check in the code for this particular case. Let's go to where we pre-cache the model, and what we're going to do is change it, add a condition, slight condition. We're going to say if model is not equal to 0, 0 being an empty model, which is what it turns if it's an empty model, then we do this here bit of code, then we will pre-cache it. So if it's not 0, we will pre-cache it. Else, what we're going to do is type alert at console, and then we're going to start writing some stuff. Oops, inside it. WIP underscore static mesh. Mesh space error, just so we know what class is throwing this error. Model failed to load. I'm going to do a new line, so that gives us a new line. And I'm just going to put a little information thing after that, saying that I am setting model, setting model null.mdl in its place. And then we do the little pre-cache here again. We're just going to copy this real quick. And we're going to pre-cache null.mdl, which, God forbid, I hope exists, unless somebody's removed it, but it should exist because I've added it to the game. And I'm just going to hard code the string to its position, which is models null.mdl. And the same goes for setting the model itself. Just place it in there. Alright, so there's probably also another check you can do here to see if this actual file exists prior to trying to load it, but for now, for what I need, this is more than enough. So let's test out this bit of code. Build solution. Great. Now this currently has nothing set to it in the model. This is what we're looking for. And if we run this, build this level, we should see no model loaded in its place. There we go. So yeah, if we create something, an entity that has no model path, we're going to see this clear indicator that something's wrong through a no model loaded animated model itself. And that's actually pretty much it for the most part. You can check out the final code, which will be fully commented, as well as the final FGD. Actually, while I'm speaking about the FGD, let me just point this out to you real quick. I'm going to grab the finished FGD that I have from my Where is Poppy folder. And the mod, here we go. So I'm just going to open this up quick. I'm going to copy this and place that here. Now notice that I have, as the fourth parameter in these key value data thing, a tooltip set for every single one of these. And the corresponding part for that in Hammer, if I restart, wrong way around. Open. If I were to go here now and click on help, here we go, for all complete help for everything in our FGD. So for the animation sequence, it's setting an in-game animation sequence for the selected model. For the model, set a mesh to load into the game. We have our flags and our collision mode, all these things. And yeah, that's basically all you have to know. Yeah, this little help button, that's where those fourth parameters come in handy. And the third one, as you know already, was the default setting. That's pretty much it now for this tutorial. I don't really have anything else to cover. I want to give special thanks to Sam Vanier, aka Solo Killer, who helped me understand quite a few things in the engine to get this tutorial up and running, and also Elias Ringhauge, aka Elisar from ModDB, who wrote a really good tutorial on the Half-Life collision system and helped me figure out how these temporary entities can be used for rendering a bounding box around your model. So I hope this tutorial helps you get to grips with programming in Half-Life. And be sure to check out the written tutorials. It goes into depth a little bit more on what you can't really cover in a video. So until next time, take care.